When we build massive physical structures like skyscrapers, we never guess how much steel or glass we need. We rely on precise mathematical planning. But when it comes to building large software systems, people sometimes expect developers to pull numbers out of thin air. However, clients are rarely happy paying millions of dollars based on a hunch. Imagine sitting in a pitch meeting. The client wants a new online banking system, and they immediately ask you three things. How much will it cost? How many developers do you need? And when will it be done? To earn their trust, you need a logical, repeatable way to estimate those numbers instead of relying on intuition. That brings us to the constructive cost model, or COCOMO for short. It is the industry-standard mathematical framework for estimating software projects. This model was introduced by software engineer Barry Boehm back in 1981. He didn't invent the formula out of thin air. Boehm spent years analyzing data from dozens of successfully completed real-world software projects to see exactly how much work they actually required. The result is a highly reliable formula. COCOMO takes project planning out of the realm of blind guessing and turns it into a verifiable mathematical science based entirely on past evidence. Before you can run the COCOMO formula, you need one primary piece of information: the total estimated size of your software program. We measure this size in a unit called KLOC, which stands for kilo lines of code. 1 KLOC equals exactly 1,000 lines of code. Think of lines of code like the raw bricks needed to construct a building. You have to know roughly how many bricks you are laying before you can hire a crew. Because of this, every single COCOMO estimate, no matter how complex the final software will be, must begin with an accurate baseline KLOC count. Size alone doesn't tell the whole story. 50,000 lines of code for a simple phone app requires a very different amount of effort than 50,000 lines of code for a safety-critical medical device. It's the difference between building a large storage shed and a small bank vault. This comparison matrix shows how COCOMO handles this by breaking projects into 3 categories. The first column is for organic projects. These are small, familiar projects with flexible requirements, like building a basic calculator app. The second column shows the middle tier, semi-detached projects. These involve medium complexity, a mix of experienced and junior team members, and moderate constraints. A banking inventory system fits perfectly here. Finally, the third column represents the highest complexity tier, embedded projects. These systems deal with strict hardware limits, high risk, and real-time operations, like the control software for a spacecraft. Identifying the correct project category is the most crucial step in this process. Your category dictates exactly which mathematical multipliers the COCOMO formula will apply. Once you have your size and category, you have to choose how precise you want your math to be. Boehm created 3 different versions of COCOMO that project managers can choose from. The first is Basic COCOMO. This is the simplest version. It uses only your raw KLOC input to generate a rough, quick estimate. Next is Intermediate COCOMO. This version is more realistic because it adds what we call cost drivers. These are real-world factors that account for things like how experienced your team is, the software tools they use, and the hardware limits. The most advanced model is Detailed COCOMO. This version breaks the overall effort down phase by phase, calculating exactly what is needed for analysis, design, coding, and testing individually. As a project manager, you have to balance your need for extreme estimation accuracy against the extra time and data required to calculate the more detailed models. So what actually happens after you plug your KLOC, your project type, and your chosen model into the math? Looking at this flowchart, we see the first 2 critical outputs. The initial input processes through the formula and gives you the total effort required, measured in something called person months. You can think of 1 person month as the total amount of work a single developer can finish in 1 month of full-time work. It also gives you the development time, which is the total number of calendar months the project will take. From there, we get our third output, team size. The formula calculates this by dividing the total amount of work by the number of months the project lasts. Finally, the flowchart concludes with project cost. This converts your estimated human effort and time into actual dollar amounts, factoring in developer salaries and your required infrastructure. These 4 metrics provide a complete, actionable roadmap. You can now walk into that pitch meeting and confidently answer the client's questions about timelines and budget. To summarize, you estimate the size of the software, select the complexity category, and feed those into a specific formula to yield precise project planning metrics. Instead of crossing your fingers and hoping your initial guess was close, you now have a structured, logical reality to work from. COCOMO demonstrates a simple truth. Reliable software is not created through guesswork. It is rigorously engineered and constructed using exact digital blueprints.